Hello, my name's Danny Wallace and this is my SEE 712 final project video. The case has been custom designed and 3D printed. It includes cutouts for the speaker, USB lead and the Bluetooth module antenna. The top panel houses the sensors with a cutaway to allow sunlight into the UV, the on-off button with an LED, a sync LED to show when the GPS sensor has affixed to the satellites. The LCD shield is flush mounted and there are custom buttons to allow activating the LCD shield microswitches. The unit has an internal 3S LiPo battery enabling fully portable operation. Startup sequence scrolls the student information at 5 seconds and clears the information off the screen at 10 seconds. To test the GPS sensor and reporting, the unit was taken for a short drive in a vehicle and compared with the onboard navigation system, latitude and longitude. When converted to degrees, minutes and seconds, the data logger can be seen to align with the vehicle's readings. The 4 locations tested in the vehicle are shown here on the map and they line up with the fence line of where I live. The system was also tested at night time and can be seen here on Barrow Island. UV information is updated every 10 seconds with a check against the threshold every minute. To check the accuracy of these timings, a print statement was put inside the code along with a 20-second loop which is independently timed. These were monitored in the Arduino IDE serial monitor with a timestamp. The UV threshold can be set with the up and down buttons to a maximum of 11 and a minimum of 1. The display uses a solid block character to show the UV bar graph and the outline block character when showing the threshold. The level has been left here at 3 to enable the 1-minute alarms to be heard. Saving the eeProm data is disabled by clicking the left button and enabled by clicking the right button. When connected to a computer and the Matlab script is run, the data can be uploaded and plotted on graphs showing the UV threshold, the UV reading and the GPS location. An interrupt is used to generate an accurate 1 millisecond timer for the system. Timer 1 is used to generate pulse width modulation used to drive the buzzer. All coding is done at low level. There are no libraries or high level functions used. This is a list of the X-Factor features or features that are over and above the minimum project specifications. The case has been designed in Autodesk Inventor and 3D printed. It includes cutouts and dedicated mounting tabs. We've also 3D printed small buttons to allow access to the microswitches below. The unit includes a Bluetooth module to send UV readings to your phone. The select button is held down while the unit is powered up. You'll have access to the test menu. Here you can test the LED, the buzzer, Bluetooth comms, the UV and GPS sensor, current battery voltage, and you have the option to save the current GPS coordinates in eeProm. This will later be sent to Matlab to be used on the graphs. The sync LED will give a flash when the GPS has a fix similar to its onboard LED. The unit has a small inbuilt power supply to derive 5 volts from the 3S LiPo battery. It includes a relay switching circuit which enables the battery to be left installed whilst external power is supplied through a USB lead. The battery voltage is monitored and the system will alarm if it falls below 10.2 volts. Two custom characters are used to display the sad face emoji. This is displayed when there is no GPS signal or when the UV readings rise above the threshold. The UV reading and threshold are both saved to eeProm and sent to Matlab. To save memory space, both values are saved to the 1 byte using a high and low nibble for each value. Latitude and longitude are also saved to eeProm and sent to Matlab.